Alrighty, today, Chemistry 20s, our focus is going to be on calculating the concentration of ions. So here's one video on how do I figure out if I have a solution, how much ions am I producing when this solution is dissociating. And so when we look at this notes guide on concentration of ions, it walks you through the steps and it says, how do I calculate the amount concentration? We also call that the molar concentration, and that's calculated in moles per liter. So first up, you're given a chemical and you have to write out your dissociation equation if it's a soluble ionic compound. If it is an acid, then you would ionize it if it is a strong acid. So once you've written out your ionization or dissociation equation, make sure you balance it correctly, and then you are going to have some ions being produced. And so the concentration of those ions is going to be a multiple of what the original compound's concentration was. So it's kind of like a mole ratio is what we're looking at. And then square brackets is how we indicate that the amount concentration is a moles per liter value. So let's do a couple of examples here. And our first example is on page 211 of your textbook, if you want to follow along. And it's asking for what is the amount concentration, so the molar concentration in moles per liter of aluminum ions and sulfate ions when we have this mole per liter solution of our original starting compound, the aluminum sulfate. So a couple things to notice. How many sig digs do we have? Well, we've got 2 sig digs in that original concentration of our solution. And so now we're just going to start going through the steps. So first up, what do? I write out my dissociation equation. So this is soluble. It breaks apart into 2 aluminum ions and 3 sulfate ions. So these numbers out front, these coefficients, these guys are going to be our multipliers when we're going and calculating our ion concentrations. Okay, so here's how we're going to do that. Okay, and double check your atoms and check your charges every time you're writing these dissociation equations. So I have 2 aluminums, that's good. 3 sulfate, looking good here. 2 times 3 is 6 positives. 3 times 2 is 6 negative. That adds up to 0. Here's a compound. It's neutral. It adds to 0. We're good. Our atoms, our entities, our ions are the same, and our charges are balanced. Okay, so now that we're done that, we can move forward and begin with what do we know? So the equation, or the question, I guess, has told us we have 0.4 moles per liter. That's our starting compound. What are we trying to do here? Well, we got to find this guy, the aluminum ion concentration in moles per liter, and also this guy, the sulfate. What is his concentration in moles per liter? So we're just going to write a square bracket and write down, well, what is it that we have? Well, from this equation, we have this much of our starting compound, the aluminum compound. And then it's basically a mole ratio. How much of the aluminum? Well, there's 2 moles of aluminum for every 1 of the aluminum sulfate. So that's how we do. It's a 2-to-1 mole ratio. Then we're just going to cancel out anything that we can. So sulfates cancel, moles cancel. What do we get? 0.80 moles per liter of the aluminum ion. So it's very similar to stoichiometry, just doing a mole ratio. We've got 2 of these in our equation to 1 of those, just based on the coefficients. So then what's going to be the mole ratio for our sulfate ions here, guys? Well, we're going to have to look back at our balanced dissociation equation, and I see that there are 3 moles of the sulfate, again, for every 1 of the aluminum that we are starting with. So when we set up, here's what we're starting with, 0.4 moles per liter, and now I've got, look at that, 3-to-1 mole ratio. Cancel out aluminum sulfate, moles, and I end up with 1.2 moles per liter. Now, have I checked, do I have the right number of sig digs? Remember here we had 2 sig digs. Do I have 2 sig digs here? I sure do. The leading 0 does not count, the 8 does, and the 2 does. And here, and the 0 does. and I've got 1.2. So that's 2 sig digs there as well. Do I have my units in moles per liter? Yeah. And have I identified the species, the entity, the thing? Yeah, I've got aluminum, and I have my state is aqueous. Okay, so make sure you're putting all those things in your answer. And then you can just summarize what is the amount concentration. Aluminum, 0.8 mole per liter, and sulfate was 1.2. Okay, so it's very similar to what we have done with stoichiometry, and it's just like doing a mole ratio. And don't forget to show your units, make sure you're canceling things out correctly, and make sure that you are having your final answer with correct sig digs. So here's another example. We're looking this time for the amount concentration, so moles per liter, of barium ions and hydroxide ions. So we started out with 5.48 grams, and here I've made a typo. This should read 5.48 grams of the barium hydroxide. And I am weighing it out, and I'm going to make up a solution, and I can use my periodic table to find the molar mass of the barium hydroxide. So remember, you're looking at the barium, and then you have 2 oxygens and 2 hydrogens. You add them all up. There's the molar mass in grams per moles. And they've also given us a volume of 250 mils, but I want to convert that into liters, so I divide by 1,000. So next, I write out my dissociation equation. I write out all the information I have, and now I'm going to find out what is the concentration of the barium hydroxide. Just like the last question, I'm going to start with the barium, this guy here, and then I will be able to use the mole ratio. So 1:1 for that guy, but this is a 2:1 ratio for the hydroxide to the barium hydroxide. Okay, so I go ahead and I do my stoich. This is just like you have done previously, except it's using solutions. So I've got grams to start with, and I'm going to cancel grams out by putting it on the bottom. And now what do I have? Well, I have moles on top. And what do I have on the bottom? Well, I have liters, and that's what I'm looking for, an amount concentration, a moles per liter molar concentration. So now I've got this number on my calculator when I punch these values in, and I am not rounding it yet. I'm going to keep all these numbers on my calculator in order that I can do the next step, because now I have to find out how much barium ions do I have and how much hydroxide. So again, I'm going to use just like a mole ratio. I see there's 1 mole of barium here. For how much of these guys? 1 mole of the barium hydroxide. So this is a 1:1 mole ratio. And I don't even have to do any math on my calculator. All I have to do, though, is now round my answer so I have the correct number of sig digs. And that means that I'm now going to have 3 sig digs in my answer, because here is 3 sig digs, here is 3 sig digs. Okay, so correct answer, I have my species, it's barium, I have the correct state, I'm good to go. Not quite done the question yet, though, because now they ask me for the hydroxide ion concentration. And so what am I going to be using here? What's my mole ratio going to be? Well, if you set up 2:1 mole ratio, you're right. There's 2 hydroxides for every 1 barium. Okay, so I would go ahead and I would punch that out onto my calculator. And then I would get my final answer, and I would round it to 3 sig digs. Okay, so now here's another example. This one's a little bit different, where we're not given the starting compound, but instead we're given the ion concentrations, and we're going to have to work backwards. So here's what I mean by this. In this equation, they are telling us that I'm looking for the mass of magnesium bromide, this guy's mass, and they have told me that I know the ion concentration of bromide ions. So same deal. I'm going to write out my dissociation equation. That's always my first step. And so the magnesium bromide is making Mg2+ ions and 2 bromide ions, because he's group 17. He's -1 charge. I've got the concentration and the volume. I write down everything that I have, and then I'm going to work backwards to find the mass. So here on the next page, you can just follow along with me. I have this concentration that I'm starting with, but this time it's of the ion, the bromide ion. So what is the mole ratio? Well, there's 1 MgBr2 to every 2 bromides. So it's a 1:2 mole ratio. Okay, so let's go ahead and we will continue on with that. Great, so then I can cancel the bromide ions and moles. And here is my concentration of this starting solution that I began with. So I'm working backwards. Now from concentration, I have to work and go and find the mass of this compound. All right, so let's see how we will do that. Well, we've got the concentration, and you can see liters on bottom times the volume, and the liters cancel. Now I'm working in moles. Now look at this, moles times my molar mass, moles on top and bottom are going to cancel. And what am I left with? Aha! I'm left with grams. So I just found the mass in grams. All right, so mass in grams, 41.427 whatever 5 grams. I'm rounding it to 2 sig digs. I'm limited by this value here. My concentration was 2 sig digs. So I'm writing my final answer with correct sig digs, correct units, my entity, correct state, etc. Okay, so that was a couple of examples for you. And now if you'll notice, you're going to work on some practice questions. The answers are in red right after each of the questions. So again, this square bracket means the concentration of this particular ion. Make sure that you guys are showing your units and you're showing your sig digs. You don't have to do the entire booklet. I would suggest you do these questions. If you want to do more for extra practice, you can, but we've got a couple more booklets to work on this week. So go ahead, get a start on that. And as always, if you have any problems or questions, I'm just an email away. So michelle.ledeen@ghsd75.ca. That's it, guys. We'll talk to you later.